Okay, let's talk about 53 through 61. In problems like number 53, you are trying to factor. And this is a really crucial skill as you move up in higher levels of math. X squared plus 4x plus 3. To really understand factoring, you have to understand FOILing. So I'm going to talk about that for just a second. What we're trying to do is find a problem where we factor it, as in the two parts that multiply together. Those are called factors. We're trying to break it up into two parts, and we usually put them in parentheses like this, so that when we multiply out this part and this part, we will get this answer. All right? So, for instance, let's say it had been x plus 4 and x minus 2 or something. If I multiply that out with FOIL, first, outside, inside, last, the firsts make x squared, the outside makes negative 2x, the inside makes positive 4x, and the lasts would be this number and this number would make negative 8. I'd have x squared, and then these two together make plus 2x and then minus 8. All right, that's an example of one that's a FOILing problem. And the reason I bring that up is that we're trying to make this into two factors which will then multiply out to this answer. All right, so we're trying to break it up. So you always make two sets of parentheses like this. And then the first numbers here, or positions, those spots, when you multiply them together, they got to make that. So if you have an x squared, it's really simple. You just put x and x. And then the last two numbers, this one's here and here, they have to multiply together to make that. Okay, so 3. Well, we made this nice and simple, so it didn't have to do a lot of thinking here. You got to go 1 times 3 to make 3. Those are the only factors of 3, okay, because it's a prime number. So if I have 3, 1 as my factors there, then I go, well, what's left? I just have to put a sign in here, and that's really easy to figure out what sign, because there's only positives in the problem. It must be plus and plus. Now, how can you tell if you have set up your factors right? If I multiply it out, I better get my original problem. So I go firsts, x times x, x squared. Outside, plus 1x. Inside, plus 3x. And lasts, 3 times 1, 3. So I've got x squared plus 4x plus 3. Okay? I got the original back that I wanted. So my answer's right here. X plus 3 and x plus 1. All right, so that's your basic factoring. This one's just a little more complicated factoring because it involves some negatives, and my last number here isn't prime. And so I still set it up with two sets of parentheses, and I'll say x and x. That'll make my x squared. And then I can look at what would go here that would multiply to 8. Well, I could use 4 times 2. I could use 1 times 8. There's several things I could use. So basically, from here, it's trial and error. Now, you can do smarter than just guessing, but basically, you just got to try a bunch of things until you find out something that'll work. How do you know if it works? You multiply it all out. Now, I can see, since I have negatives in my problem, that I have to have at least one negative in my problem, either in this spot or in this spot. All right, so now let's think it through. I have to have these two numbers here, here and here, have to multiply to make negative 8. If they were both negative, negative times a negative would make it positive. So we need one of them to be negative. All right, if one of them is going to be negative, I can just guess and then make the other one positive and then try it and see if it works. Or sometimes you can be smarter about how to decide which one to make negative. If I know that when I'm done, my outside term and my inside term have to make this part, I should set up the negative so that, since there only one of these two can be negative, make the negative on the one so that the answer is going to come out to be, if I want it to be a negative, I want the bigger one to be negative. All right, so this one should be negative and this one should be positive. But really, guessing and checking would have worked here pretty well, because at the end, I really should check anyway. So I could have just tried making this positive, and if it doesn't work, well, you learn something from that. And you try it the other way. So if this is x minus 4 and x plus 2, I'm going to say x times x is x squared. And then I do my outside ones plus 2x, my inside ones, minus 4x. And my last ones, that and that, is negative 8, sorry, x squared minus 2x minus 8 is my final answer. Is that the same thing as what I had here? Yes, it is, so it worked. So I'm going to clear off my screen of a bunch of kind of messy writing here, and there is the combo that worked. Now, one more tip for you. If you're going through this and you're kind of guessing and checking, and you just kind of go, okay, well, I don't know which one's positive or negative, but I know one of them's got to be negative, so I'll make that one negative. And you try it. Well, my first would make x squared, my outside would make negative 2x, my inside would make positive 4x, and my last would make negative 8. If the middle two terms are making the opposite of what you want, like in this case they make positive 2x, and I really wanted negative 2x, if they're making the opposite of what you'd want, then you can always just switch the two signs, okay, and make this one negative and this one positive, and you know you'll have the right answer. As usual, my advice is to check it, because it isn't that hard to check it quick. You do first, x squared, outside, 2x, inside, negative 4x, and last, negative 8, and yeah, that's what I wanted. Okay, so that's a little more advanced factoring. Here's the next step up, and that's where if you look at everything, yes, you could break this into two parts and try to find something that will work here and here, and but the first thing you should really do on a one with big numbers like this is look and see if there's something buried in everything. There's a GCF here, a greatest common factor, something that goes into everything, and it is 6. And I also should look and see if there's an extra x in all of them, but there isn't. There isn't enough x's. There's no x there, so I can't factor an x out. But I could factor a 6 out. Once I got that 6 factored out, then I should see what I have left. When you're factoring out something, factoring out a 6 like this means dividing it by 6 is really what I'm doing. So I'm dividing each part by 6. So I can take 6 divided by, or 6x squared divided by 6 would make x squared. And then 12x divided by 6 makes 2x. And negative 18 divided by 6 makes negative 3. All right? And then some people just feel so good that they got that 6 out that they say, there's my answer. Wrong. It needs to keep going. If it can, anyway. And this one can't. So I can keep factoring this out and say, now I'm going to factor out this part. And this part has, let's see, x and x. And then what can I put here that would make a 3? Well, 1 times 3. But one of them's got to be negative, and one of them's got to be positive, so that this will come out to negative 3. All right, so which one should I make negative? Well, I want the answer in the middle here to be positive 2x. So I want the answer to come out positive, so I should make the negative one the smaller one. Okay? And I'll make the positive one the bigger one. And now, double check it. That's the smart way to do it. So I go x times x makes x squared. I still have my 6 on the outside here. And then I have outside plus 3x, inside minus x, or minus 1x. And the last is minus 3. Final answer, 6x squared plus 2x minus 3, and that's what I had. And if I really want to be really sure I'm right, I multiply it all the way out. 6 times the x squared makes 6x squared. 6 times the 2x, 12x. 6 times the negative 3 minus 18. And is that the same as that? We'll check. Yes, it is. So I have done it right. There's my factored answer. Okay? So look for the GCF that can come out of all three if you have big numbers like this. Okay, next. This kind of factoring is called the difference of squares. That's a perfect square and that's a perfect square. Okay? And x squared, and it's a difference of squares because that's a minus. Minus is a word for difference. So a difference of squares, whenever you have a perfect square and a perfect square, you can break it up like this and say this has got to be x and x, that's the square root of the x squared, and then 5 and 5, because that's the square root of the 25. And one must be plus and one must be minus, because when you multiply 5 times negative 5, I will get negative 25. All right? And this kind, again, any kind when you're factoring, I would multiply it out and make sure you got it right. X times x makes x squared, Outside makes negative 5x, inside makes positive 5x, and those cancel. And then 5 times negative 5, negative 25. Okay, so yeah, did it right. Okay, so that again is called difference of squares. Another one like that would be if I had said 4x squared minus 16. And that's a difference of squares. It's just a little more complicated. You still have two parentheses. Still take the square root of this, 2x and 2x, and the square root of this, 4 and 4, and make one positive and one negative, and there would be my answer. But this would be really a kind of a tricky one because I really should have factored out a GCF from both of them first. Okay, so I'm going to back up a little bit and follow my own rule, which is to look for a GCF. What goes into both of those? 4 does. 4 goes into it, and what do I have left? X squared minus 4. And then that's a difference of squares. And I can go 4 and then break this up into x plus 2 and x minus 2. Okay, so there's another example like a difference of squares. Next kind. These are probably the getting into the hardest kinds of factoring. And you still are going to end up with 2 sets of parentheses. Okay? But I can't use x squared, or I'm sorry, x and x here because I need the first terms to give me 3x squared. And so this is still not the hardest kind of factoring because that really is only one way to do it. 3x and x. All right, that'll give me my 3x squared. And now I'm going to figure out something that will multiply to 2. But I can't do the other little trick where you go, do you multiply to 2 and add to 7? That won't work in this case. So I got to say, all right, they'll multiply to 2. Well, that's got to be 2 times 1. And since thankfully there's only positives in the problem, it must be plus. And I can double check to make sure I'm right by starting doing the first outside, inside, last. First, 3x squared. Outside, plus 6x. Inside, plus 1x. And lasts, plus 2. And that gives me 3x squared plus 7x plus 2. And is that what I had in the first place? Yes, it is. Okay, so that's factoring when your lead coefficient, okay, the number in the front, is not just a 1. In other words, you've got something x squared, not just plain 1x squared. All right? And again, this is the kind where it's just a prime number in front. So these still aren't the hardest kind of factor. All right, moving on. Factor AB plus AC. Well, we were doing complicated factoring before. This goes down to simple factoring. And I'm just looking for what do they have in common. They both have an A in them. And so I can factor that A out. And what do I have left? Well, again, a lot of people don't really understand what they're doing when they're factoring. What you're doing when you're factoring is you're dividing both parts by A. And then we're putting it back in the front. So we're multiplying by it in the front. And to find out what I have left, I need to divide both parts by A. So the A over A will cancel and make 1. So it's 1B over 1, which is really just B. Plus B's will cancel, C. All right? So if I had ABC plus A BY, I could factor out in this one an AB because they both have an AB in them. And I put AB in the front, parenthesis, and then what am I really doing in a factoring? I'm dividing by it. And then these would cancel, and these would cancel, and I'd have C plus Y left. And with a lot of problems in math, you can check yourself by just multiplying it up. AB times C is ABC. That's what I had in the first place. AB times the Y is ABY. That's what I had in the second place. All right. So there's some examples of that kind of factoring. Next, we are actually doing the opposite of factoring, which is foiling. And we got a first outside, inside, last. But does this one look familiar? We did something like this just a minute ago. But if you don't recognize it, just do the first outside, inside, last. The first is x squared. The outside makes minus 2x. The inside makes positive 2x. And the last makes negative 4. And then I have x squared, and those cancel. They're gone. Minus 4. It's one of those difference of squares problems. Okay, so I could have maybe noticed that. I'll make another one down here. Let's say I had x plus 6 and x minus 6. you can just notice right off the bat, oh, it's a difference of squares. So these are the square roots of the thing that I have, and so I have x squared, and I have 36, and then it's a plus and a minus, so I have a minus. See what I'm saying? You can do them a little faster if you notice they're a difference of squares. Oh, I dropped my eraser. Let's move on. X plus 2 and x plus 3. Well, this is just a plain old-fashioned FOIL it out kind of problem. It's a product of binomials, and I do first x squared. Outside, 3x. Inside, 2x. And the lasts, 3 times 2, 6. So you go x squared plus, and these go added together, 5x plus 6. All right, so this and this are the same thing. They're just written in different forms. So if you really want to check yourself to make sure you did it right, what you can try to do is try to fool yourself into thinking that this is the problem and say, what could I factor it into? Well, I could factor it into an x and an x, and then what multiplies to make a 6? Well, I could either use 6 times 1, or I could use 2 times 3. And you think to yourself, these numbers will multiply to 6 and add to 5. Okay, so what multiplies to 6 and adds to 5? 3 times 2 does. All right. So I know that I did it right because when I factored it out, I got the same problem I had in the first place. Well, let's move on. Number 61, x plus 4 squared. Oh, painful. This is that one I've talked about before where if I have something squared like this, don't think x squared plus 16. Oh, it's so frustrating for your math teachers. Because really, when I take x plus 4 squared, what I mean is x plus 4 times itself. That's what squared means. And this is a whole different answer than the other. So this would be x plus 4 is times x plus 4. First, x squared. Outside, 4x. Inside, 4x. Lasts, 16. Final answer, x squared plus 8x plus 16. All right? And that's all I have for you on this section.